Good morning. We are live and we are having trouble with focus. There we go. Oh my gosh, I've had those mornings. The camera's having that morning. It's like, oh, blink, blink, blink. I don't know if I'm really up for this. But it's fractions. So we're going to have to bring our A game because this is fraction review. I know not everyone's favorite thing, but what I'm hoping we can do is I'll review a little bit. We will rummage around in the back of your brain. You'll find all the places where you've been storing all your fraction facts and hopefully get everyone up to speed so that the rest of the semester is fairly comfortable because fractions have a lot of interesting rules. They're slightly different than the things we have to remember for other types of numbers. So let's get started. The interesting thing is we never start with addition of fractions. We always start with multiplication because why? Multiplication always loves you. Yay! Multiplication really truly always loves you. And I know this is tiny if you're not using the handout. So let me make these slightly bigger. Again, anytime you're scared of something, anytime something is seeming a little daunting, make it bigger. I know it's counterintuitive, but it really works. So first thing, we've got multiplication. With multiplication, everything is allowed. You can multiply across the top. You can multiply across the bottom. And I know some of you are looking at this going, wait, no, you're making a horrible mistake. I'm not really. I just wanted to show you. You can just go ahead and multiply across the top and deal with reducing later. Or you can go ahead and notice, wait, there's a 3 on top in the numerator. There's a 3 on the bottom in the denominator. I could cancel. And being a teacher, I have to cancel and leave little ones. I know that it's a little formal, but it does help to remind you, okay, they canceled completely. So could you cancel it here? Absolutely. Anything on top with anything on the bottom, as long as it's multiplication. Okay, so I think I've got up top, oops, switch back, 2/4. Now, can I reduce this further? Absolutely. The 2 is divisible by 2 once. The 4 is divisible by 2 twice. And so the whole thing is 1/2. Now, could I have done all of this over here in the original? Absolutely. You get to choose to do it whenever you like. I try to spread it out a little bit because I think it's easier to read the notes. So anyone who's just reading the notes will have an easier time of it. So there we go. Our first fraction problem. Not dead yet. Let's keep trying. Not with the death thing, just that we have persevered. We have survived our first fraction problem of the semester. Dun, dun, dun. Okay. So slightly larger, this is -3/4, and that whole thing is being squared. So one way to pronounce it is the quantity -3/4 squared. What this actually means is it means -3/4 times -3/4. Now I happen to know a little bit about minuses and negative signs. You ready? What? Oh wait, where's the camera? There we go. What? Two minuses coming together? Ah, they're a plus. Okay, so this minus and that minus. Let's see, what color do I want to use? I'll use yellow. Let's see if we can keep it from smearing too much. It smeared a little bit. One problem with writing big, when you write big, sometimes you end up running out of space. Okay, so there we go, a little smeary, but the idea is I personally, and this is a personal thing I do, but I like to get rid of the signs in the beginning if I can help it. When I'm multiplying or dividing, the signs are just in my way. I want to really get down to business. So I take a look, minus there, 2 minuses makes a plus. And now I can just multiply my 3/4 times my 3/4. Now, notice that when you multiply two fractions, right, you multiply across the top and across the bottom. And I just want to point out that, you don't have to show this many steps. I know a lot of people are just rolling their eyes saying, oh my gosh, this is so much work. And Godzilla's here to say, you know what, it's okay. It's okay. You can do it. You can climb out of the ocean and try to stop man's inhumanity to the environment, right? We can do this. Okay, so 3/4 times 3/4 is 3 times 3 or 4 times 4. So notice that the 2, the squared up here, basically can be given out to the numerator and the denominator. These are hard words. This is why we say top and bottom sometimes. So minus, the minus right there is going to make this kind of messy. But once we dealt with the minus, then we can deal with each of them just gets the squared. So basically, I got a 9 over a 16. Woohoo. Now, personally, again, I don't think you need to box things. Everybody's got their own personal style. So if you want to put boxes around, I think in this case, when things get a little messy, I do think that there is something nice about a box that helps your eyes settle on where the answer is. So if you choose to box it, that's awesome. Or you can not box it. Your choice completely. Okay, next up. This is a very dangerous problem. Dun, dun, dun. And it's winking at you. Sometimes math does try to kind of pull you astray. Don't fall for it. The 3s are winking at each other. The 2 and the 4 are winking at each other. But what is this? It's division. Division is not, we don't actually divide. What do? We can do this Dora style. What do you do with the division? You don't actually divide. That's right. I hope you said something. I mean, maybe you just said mashed potatoes, but again, Dora the Explorer style is, that's right. You're so smart. You change the division to a multiplication because we know how to multiply. And you flip the second fraction upside down. And here we go. Reciprocal. So you get the reciprocal of the fraction, the second one. Okay, so let me rewrite over here because, I ran out of room. This happens a lot to me. And when we actually get the fractions sitting where they should be, we see, oh, nothing actually reduces. When we multiply across the top, I get 2 times 4 all over 3 times 3. That's 8 over 9. Ugh, nothing reduces. So first question, last question. All the questions people usually ask me is they look at my work and they're like, whoa, do I have to write out that much? I could have done this in 2 steps. And the answer is no. I am writing all of this out to begin with because I'm trying to remind everyone about their fraction rules. It may have been a long summer. It may have been 10 years. So this is just a reminder for where we stand with the fractions. Okay, woohoo, woohoo. Page 1 done. Just a couple more fraction problems left. There are much more exciting fraction problems in the homework. This was just intended to kind of whet your appetite. This is an amuse-bouche, if you would like. And so you may find that the homework is actually a lot harder. It may be easier. I want to remind you that anytime you get stuck, do not put more than half an hour into any one homework problem. Ask for help. See me, talk to other students, talk to your friends, talk to your friend's dog. It can calm you down, help your brain collect itself and come up with some great ideas. Talk to tutors, talk to, your grandparents, talk to everybody. Everyone should be talking about math all the time. Okay, so these last 2 are not necessarily intended to be hard, but I thought that they were pretty weird. And I wanted to remind you of some weird things that fractions can do just in case you're like, wait, what? So this number 4 is a little bit weird because we've gone and mixed decimals and fractions, and they do not mix. We're talking the sharks and the jets. We're talking, oil and water. We're talking, peanut butter and mayonnaise. These things should not go together. And no shame, but I really don't think those things should go together. So first thing we want to do is figure out what the heck is going on. Now, if I ignore the decimal, I see the numbers 26 and 39, and I think to myself, I'm reminded of 13. And in fact, I want to point out, and this is the sort of thing where you may look at this and go, wait, what? But the more examples you see, the more your brain is likely to go, oh, I've seen this before. What if I take a look at 2.6 and I say, this is actually 2 times the quantity 1.3? Take a look at that, see what you think. 2 times 1.3, 2 times 3 is 6, 2 times 1 is 2. And 39 or 3.9, that's 3 times 1.3. And the interesting thing is even though these look just like a mess, in fact, they had a lot in common. They had the 1.3s. And when I cancel the 1.3s, I get 2/3. Now, what if you did this on your calculator? Because you can totally do math on your calculator. Clear. 2.6 divided by 3.9. What if you did the fraction? Oh, you can't see that. That's in the ring. Sorry about that. 2.6 divided by 3.9. You would get 0.666666666, and eventually it gives up and it just says 7. It rounds for you. Some calculators do, some calculators don't. This is the decimal approximation for 2/3. So if you did it, if you divided it, you would get that hint. You would be like, wait, that's 2/3. There's 2/3 in here, and that could help you. So sometimes you can use a calculator to kind of do the problem kind of backwards and figure out, okay, where am I supposed to head in this? Okay, that's it. It was just a word problem. Here's another word problem. It is radical 0.25, or the principal square root of 0.25, or just square root of 0.25 if you're being informal. And so the first thing to note is that calculators will absolutely, I would have gotten away with it too if it weren't for that darned ring light. Okay, so you can actually calculate on a calculator. So I'm going to go in. I have to press the second, and then the x squared key, which will give me that square root. 0.25. I'm going to close the parenthesis. Depending on your calculator, sometimes they get upset when you don't match the parentheses. Sometimes they do. I'm just going to be, formal, and I see it's 0.5. So on a calculator, it is, on my calculator, I should say, yours might be different. I have to do second and then get to the square root key or the radical key, and then 0.25. And again, calculators will usually be very forgiving. You can leave off that initial 0 and just have 0.25, and then equals or enter, and I get 0.5. Woohoo, I'm done. But I imagine you know that was not the reason I gave you this problem, to practice calculators. I mean, it's good to practice on the calculator by hand. I just wanted to point something out, that radical 0.25 this is 0.25, that's actually radical 1/4. And then I want to go take you through some square root facts, or some radical facts, which is, if you've got a fraction inside a radical, you can actually split up the radical to the top and the bottom. Now, some people do know how to do this just straight up. If you know how to find radical 1/4, awesome. If you don't, split up the radical and take it in pieces. Square root or principal square root or radical 1 is, you're right, 1. Square root, principal square root, radical 4, 2. Remember, if it's just the radical sign, we want the positive one. And we get 1/2, which is equal to 0.5. A caveat: sometimes WebAssign wants one or the other, and it will not accept the other, even though these two are equal. WebAssign is looking for one or the other, and sometimes it doesn't tell you that. So if you ever get to a point where you're sure you've got the right answer and you're frustrated because WebAssign is like, nope, that's wrong, talk to me. I have access. I can actually look inside of WebAssign and see what they want for their correct answer. So check with me, because sometimes if you enter one, they want the other, or something like that. I know, WebAssign. Rah. Okay, so woohoo! That's our fraction review. Have fun with the fractions. Math on. Woohoo!